Hello friends, in this video lecture, we will see deadlock, that is deadlock system model and necessary conditions for the occurrence of deadlock. Before starting deadlock, let's have few things associated with deadlock. First one is resource. Whenever you want to show resource, in that case, you have to use rectangle, that is resource R. And whenever you want to show process, then you have to use circle. This process P1 is there in a circle. Then request age is there. Whenever process is requesting for certain resource, then this type of age is known as request age. And whenever that resource is allocated to process, then this age is known as assignment age. Here we can say resource R is assigned to process P. Now let's have the deadlock system model. Here we are dealing with multi-programming, multitasking or multi-processing type of environment. And in this type of environment, many processes may compete for multiple number of resources. That is to run the processes concurrently or simultaneously. And we know that the resources available in the system are finite or limited, where processes need different resources in order to complete the execution. In this scenario, if process requests for certain resources, then requested resource may not be available or it is held by another process. And in this case, then this requesting process goes in a waiting state for indefinite time. So that condition of requesting process which is there in a waiting state for indefinite time is known as deadlock. Let's have the example. Here we are having two processes, process P1 and P2, along with two resources R1 and R2. Let's say there is process P1 has held resource R1. Whenever there is an arrow towards process, then it is known as assignment age. We can write R1 is assigned to process P1, that is towards process. And the same process is requesting for another resource, that is R2. Whenever there is an arrow towards resource, then it is known as request age. And in this case, if this resource R2 is already assigned to process P2, then this request age will be there in a waiting condition. Means this resource R2 will be given to process P1 when it will be released by process P2. So if this waiting is there for indefinite time, in that case system will be there in a deadlock condition. Another thing is that this process P2 has resource R2. This is basically assignment age, and this P2 is requesting for another resource. This one is the request age. That is another resource is R1. So in this case, R1 is assigned to process P1 and is being requested by process P2. So this P2 will get this resource R1 when it is released by process P1. So for that duration, that process P2 will be in a waiting condition. Means that request will be delayed by resource R1. And this waiting condition is there for indefinite time. Then system will be there in a deadlock condition. So this is one of the scenario of deadlock. For the actual occurrence of deadlock, there must be four conditions. Let's have these conditions. These four conditions are mutual exclusion, hold and wait, no preemption, and circular wait. So all these conditions must be occur in a system for the occurrence of deadlock. So this must be occur at the same time, or this must be occur simultaneously. So let's have all these conditions one by one. First one is the mutual exclusion. One process at a time can use resource which must be held in a non-shareable mode. You have computer, and computer is having one resource, that is printer, and another system is there requesting for same resource, that is printer. If this printer is shareable, in that case printer will be shared amongst these two systems, system 1 and system 2. And if this printer is there in a non-shareable state, then this requesting process, that is system 2, will be there in a waiting condition. In this case, deadlock will be occur. Means this system 2 will get printer after releasing the printer by system 1. So this condition is known as deadlock. Means that printer will be used by one process only at a time. So that is the meaning of mutual exclusion. Means here you can say if another process requests the same resource, then requesting process must be delayed till the resource has been released by holding process. So that we have seen. Then second condition is hold and wait. The process which is holding at least one resource and is waiting to get additional resources that are currently being held by another process. So that condition is known as hold and wait. Process P1 has held resource R1. So this condition is known as hold condition. Means resource R1 is assigned to process P1 and process P1 is asking for another resource, that is R2. But this R2, that is additional resource, is already held by another process, that is P2. In this case, this request age from process P1 to R2 will be there in a waiting condition for indefinite time. So this condition is known as hold and wait condition. So we have taken two resources only. We can have another resource, that is R3, which is requested by process P1. But this R3 is already held by another process P3. So this condition is also known as hold and wait condition. Means P1 has held resource R1 and waiting for resource R3. So that is hold and wait. Now third condition is no preemption. No preemption means resources cannot be preempted. That is, resource can be released only willingly by the process holding it, only after that process has completed its task. Means process P1 has held resource R1 and that R1 is being requested by another process P2. So this R1 will be released voluntarily by a process P1, or after completion of the process P1. Till that process P1 will hold this resource R1, and meanwhile this resource R1 is requested by another process, that is P2. In that case, this P2 will be there in a waiting state for indefinite time. So this leads to deadlock. Then fourth condition is circular wait. There must exist a set, that is P0, P1 up to P1. That is the n number of processes of waiting processes such that process P0 is waiting for a resource which is held by process P1, and process P1 is waiting for a resource which is held by process P2. So this type of condition is also known as hold and wait condition in a circular manner. We can say there is process P0 has held resource R0. R0 is requested by process P1, and P1 has held resource R1, and R1 is requested by P2, and P2 has held resource R2, and R2 is requested by P0. Means every process is there in a waiting condition and in a hold condition in a circular manner. So this condition is known as hold condition. This one is waiting condition, hold condition, waiting condition, hold condition, and waiting condition. So waiting condition is there in a circular manner, that is known as circular wait condition. So these are the necessary conditions for the occurrence of deadlock. And thank you for watching this video.